All right, hello, seventh graders. We're moving on to day 5. All right, we're going to start with number 1. So first thing we're doing is going to review plotting ordered pairs. So not only do I want you to plot these, but I want you to label them. So for example, the first one, A, is 0, 1. So 0, first number is 0, so I'm not moving left or right. I'm just going to go up 1, put my point, and you're going to label it with the letter. Okay, the next one is 1, 3, so I'm going to go to the right one of 3, label it B. Okay, C is 2, 5, so I'm going to go to the right 2, up 5, label that C. And you can keep going, and then if you want to pause, plot all the points, and then check with me, that's a great idea. D is right 3, up 7. E is 0, 0 at the origin. F is 1, 2. G is 2, 4. H is 3, 6. All right. Let's move on to the second part. So you're going to see these equations fairly often, especially the first one, y equals mx. Y equals mx. So m and k represent the constant of proportionality, which will be also called the slope. So we're going to be talking about proportional graphs. A proportional graph is a straight line, so not curved, that goes through the origin. Okay, remind yourself the coordinates of the origin, 0, 0. So if a line goes through 0, 0, it is proportional. All right. So let's take a look at number 1. So I have a table here, and we're going to plot the points. So notice the first one, hours. So we're going to think of the hours as X, dollars as Y. So you notice my graph isn't labeled. So my x-axis over here is hours. I have my 0 here. All right, I have 1, 2, and 3. So I'm going to plot these. I'm going to make this 1, 2, 3. We really don't need to go further because in my table I only have 0, 1, 2, 3. And then my y-axis is dollars. So think about what you want your increments to go up on your y-axis. So you notice it goes from 0, 12, 24, 36. There's not one correct answer for this, but we can't go up by ones because we can't fit 36. So I'm going to choose to go up by 6s. So make this a little thinner. So I'm going to have 6, 12, 18, 24, 30, 36. Okay, now I'm going to plot my points. So I have 0, 0, right there at the origin. And then I have 1, 12. So I'm going to go to the right 1, up to 12. Then I have 2, 24. So the right 2, up to 24. And I have 3, 36. Right 3, up 36. Okay. Graph those points. We want to know if this is proportional relationship. So again, if it's proportional, is if it goes through the origin. If you connect these points, see how they make a straight line. So is it proportional? Yes. If it is, identify the constant of proportionality or the k value. So really notice back up here on our table, it says k is equal to y over x. So if you look at this table right here and you do y over x for all of these. So for example, 12 over 1 equals 12. Let's do another one. Remember, y over x, 24 over 2 is 12. If we do the last one, 36 over 3 equals 12. So when you divide them all, you get 12. So our k value is 12. So our equation, again, looking back up to the format of our equation, y equals kx. So your equation would be y equals 12x. In other words, you're multiplying all the x values by 12 to get the y value. All right, let's flip it over and take a look at number 2. So again, we want to look at if it's proportional or not. The bowling game charges $5 per game plus a fee. So you're looking where the graph starts and if it goes to the origin. Do you see how it starts right there? So that it's not starting at 0 because you have to pay that fee. So this one is not proportional because it does not start at the origin. So in other words, if I were to take these values and I were to divide them, so what I mean by that, like this point right here, this point, the coordinates of the point are 10, 1. The coordinates of this point are 25, 4. If I divide those, I'm not going to get the same number, and that's because it's not proportional. All right, number 3. Again, we're looking. Notice how I don't have a line. Well, I'm going to connect my points. And if I were continuing the other direction, you can see it would go through the origin. So is this proportional? Yes. The line goes through 0, 0. Okay. So that's all we're looking for in a graph if it goes through the origin. All right, taking a look at number 4. So the graph shows a relationship between the distance a car travels and the fuel used in gallons. Okay, so taking a look, what does the point 480 represent? So think about the 480. So 4 is the x, 80 is the y. So our x value is fuel, y value is distance in miles. So x is the fuel, so 4 gallons of fuel in 80 miles. So what does it represent? It took 80 miles used 4 gallons. What is the rate of change? Well, you notice if I were to connect these, oops, not the best line, but it's okay. If I were to connect these, it makes a straight line. It's proportional. So all I'm doing is 80 divided by 40. So the K value would be 20. But notice it says rates. We need units. So 20 mpg. You might have heard that, miles per gallon. You might have heard that on some car commercials. They say mpg. So we want to know how many miles a car would travel after 1.5 gallons. So 1.5 gallons, think about that as a decimal, 1.5. So all I'm going to do is 20 times 1.5. 20 times 1.5. Notice 30, how many miles? So 30 miles with 1.5 gallons. How many miles will the car travel using 5 gallons? So again, same thing, but this time I'm going to do 20 times 5, which is 100 miles. So what is our equation? Well, our K value is 20, so Y equals 20x. Okay. Let's move on to number 5. Family travels 75 miles per hour on the highway. Make a graph to show the distance traveled in miles is related to the time in hours. All right, so I'm going to label the x and y axis. So my time is hours. And we have our distance in miles. So I have x, I have y. All right, so 75 miles per hour. So if I look at 1 hour there, should be 75 miles per hour. So I'm just going to kind of add in these numbers here because you only see the even numbers. So that means I'm going to go 1 hour, 75 miles. So think about these increments right here. So this would be 50, 150, 250. So 75 would be in between 50 and 100. So I'm going to put my point there. Then 2, think about 2 times 75 would be 150. Notice it says 3 points, so I need one more. So there's a couple more I could do. So if I go up 75 more, I'd be at 225. 75 more, 300. I'm doing more than 3, which is okay. And you can also do it 0, because after 0 hours have passed, you've traveled 0 miles. And I'm going to continue these with a straight line. All right. Number 6, last one. We want to write an equation for a relationship between the cost of electricity and the time in hours of a local business. So the equation, we need to identify the K value. So I'm going to focus on some points here that we know. So the coordinates of this point are 220. Let's look at another point. I'm going to do this one over here. Coordinates of that point are 880. Well, we know it's proportional because it goes to the origin. So think about, remember it's always y over x. 20 divided by 2 is what? 10. 80 divided by 8 is 10. So our K value is 10. So our equation, y equals 10x. We want to draw a line, graph that represents another business that has a higher constant rate. A higher constant rate. So you should be drawing, and there's not one right answer. A higher constant rate means it costs more. So I'm just going to draw a line that's more vertical or steeper than the given line. All right. Thank you for following along. You may move on to your independent.